Today we're doing 1.4 and 1.5. We'll talk about rewriting equations and solving algebraic models. So again, this should be a review for you guys, but we're just freshening up. We want to rewrite this equation and solve for y. We need to move everything that's not dealing with y to the other side and get y by itself. So we're not solving for x, we're solving for y. So what I'm going to do is I'm going to move this 3/4 x. The opposite of adding 3/4 x is subtracting. It's okay that it has a variable. It's not a big deal. We are just going to move it to the other side. So by subtracting 3/4 x to both sides, do it to one side, I must do it to the other. Again, in algebra, you write above and below each other. Now I'm running out of room, so I'm going to go on to the side. This gives me 0, and I'm left with 5y equals 20 minus 3/4 x. And it doesn't matter if you write the negative 3/4 x plus 20 or 20 minus 3/4 x. It does not matter. You get the same answer. Now eventually we are going to solve our equations in slope-intercept form, and you'll want your x first. So let me go ahead and write it that way just for the pure fact of later on we're going to have to. So now that I've got my number, I'm going to write negative 3/4 x. Because it's a positive 20, I'm going to put plus 20. Now you notice that y is not completely by itself, it has this 5. So what's the opposite of multiplying, because that's what's happening here, multiplying by 5? Dividing by 5. Now here's the concept, is I'm dividing each component on this side by 5. I can divide everything by 5 or break it apart, and I'm going to choose to break it apart. So now I'm left with y equals, now remember when you have fractions and you're dividing by a number, you're really multiplying by the reciprocal. So it's negative 3/4 times the reciprocal of 5, which is 1/5, times x. And then 20 divided by 5 is a positive 4, so plus 4. And I'm going to simplify that. I get y equals, well, negative 3 times 1 is negative 3. And 4 times 5 is 20. And if I could reduce that, I'm going to go ahead and reduce it. But this one, that's as far as it can be reduced down. So negative 3/20 x plus 4. We've solved for y. In example 2, it wants us to take the formula, the simple interest formula. I equals the principal times the rate times the time. And we're going to solve for p. We'll look on the side where p is. P is being multiplied by 2 other components. Well, what's the opposite of multiplication? Division. All right, what are you dividing by? Everything that's not p. So r and t. If I do it to one side, I've got to do it to the other, right? What happens to the r and t on the left-hand side? Right, they cancel out. That r and t cancel out to be 1, and 1 times p is p. So now I've got p, and I'm just going to write it on this side. Flip sides. And then I have the interest divided by the rate times time. And remember, you're treating the denominator. If you had actual numbers, you would do that first and then division. So moving on to the next problem. These are just common formulas. I'm not going to go over them, but these are things that you would use. Be aware of those. Make sure you're familiar with most of them you would be using on the ACT. On 1.5, we're going to write and use a formula. So in this first part, the bullet train runs between Japanese cities, and I'm going to kill these names, Osaka and Fuka, a distance of 550 kilometers. When it makes no stops, it takes 2 hours and 15 minutes to make the trip. What is the average speed of the bullet train? Now, this is a tricky word here because we're talking about average speed, and you're given 2 different times. You're given hours and in minutes. So beware of that. But we're given distance and time. I wonder what we'd use for distance and time. Maybe the distance equals rate times time formula. That's a very common one. Distance, of course, is the 550 kilometers. The time is the 2 hours and 15 minutes. The problem is you're going to have to decide if you want to use hours or minutes. You can't use both because they're not done in base 10, because minutes are 60 minutes. So what I would do is go ahead and convert 2 hours to the number of minutes. And we know that there are 60 minutes in every hour, right? So 2 hours times 60 would give me my minutes, which would be 120. So we have a total of 120 minutes plus the 15 minutes that was already there, right? So it gives you a total of 135 minutes. Now that we have distance and time, we can substitute it in. We've got 550 equals the rate, and that's what we're looking for, the average speed, times 135. Look at your variable. What's happening between the variable and the numbers? They're being multiplied. Opposite of multiplication is division. So if you divide one side, you must divide the other side. And 550 divided by 135 is a decimal. And it's dividing by 135, and you get a decimal, and that decimal is 4.07, and it keeps on going, but I rounded. So 4.07. Now, got 4.07, but then we need to make sure that we give our unit of measure, because not only the number is important, but the unit of measure is important. So we were dealing with distance, which distance was in kilometers, right? So we got kilometers, km. And over here, 135 was the time, and 135 was represented in minutes. And we divided by that to get our answer. So divided by minutes. So it is 4.07 kilometers per minute. And if you got a different unit of measure and a different answer, you could still be right. You could do kilometers over hours, but you'd have a different, of course, answer. Okay, I've lost my mouse. So in the next part, given the water pressure at the floor of an underwater building, it was 2,496 pounds per square foot, and the water pressure is 0 at water surface and increases by 62.4 pounds per square foot for each foot of depth. We want to write a variable model, then we want to assign the labels, write an algebraic model, and then solve the model to find the depth. So we're going to write a variable model for the water pressure. And we have the water pressure, so I'm going to call it WP. The water pressure, and it is equal to the pressure of depth. I'm going to call it pressure. Of course, it's not working well today, sorry. Of depth. Times depth. That looks a little better. Water pressure equals pressure of depth times the depth. And we're going to assign the labels. What that means by assigning labels is we're going to take the water pressure and assign what it is equal to. And the pressure of depth is what it's equal to. And of course, we're looking for depth, so we won't have anything for that one. So I'm just going to type it out for you. I'm going to pause it. And water pressure, look, it says the water pressure, hey, it's 2,496 pounds per square foot. All right, so that would represent the water pressure. And then the pressure of depth increases by 62.4 pounds per square foot, which means it's adding that amount. So I'm going to pause it and type that in. Now, I've typed it in, and you notice that the water pressure, the pressure depth, and the depth that we're looking for, I called it D. You could call it X, you could call it anything you want to. The next part, we're going to write the algebraic model. So that means we're just going to substitute in the information that's given to us. And again, I'm going to type it. It just seems to be a little better font today than what we had in the past. And I'm going to change the color to red, so it's just a little easier to see the difference between the answer and what we've been doing. So we take the verbal model that we had, water pressure equals pressure of depth times depth, and we just substitute in the numeric amount for the water pressure equals the numeric amount of the pressure of depth, and we're solving for D. And then the next part is we take that answer for that problem and we are going to solve. So the opposite of multiplying by the variable is dividing. If I do it to one side, I must do it to the other. And then I just type that in my calculator. 2,496 divided by 62.4, and I get 40. So the depth is 40. Now the question is, I'm going to write D equals 40 over here. What's the unit of measure? Now if you noticed, we had pounds divided by feet squared, and then divided by pounds divided by feet. So depth should be measured in feet. And if you notice, that was a fraction, right? Fraction divided by a fraction, so you're multiplying by the reciprocal, which means that you're left with foot, 40 feet. Here you have 480 feet of fencing to enclose a rectangular garden. You want the length of the garden to be 3 feet greater than the width. Find the length and the width of the garden if you are use the fencing. And again, I'm going to use the font key. It's just been a lot better for us right today. And I'm going to change the color to red. Well, remember perimeter. That formula for perimeter is 2 times your length plus 2 times your width. And it also tells me that the length of the garden to be 30 feet greater than the width. So the length is going to be 30 greater, means plus, the width. Well, knowing that, and that my 480 feet of fencing around my garden is my perimeter, I can substitute in 480 for perimeter. I'm going to substitute the length with 30 plus W, and then I'm just going to add my 2 times the width. And then I start simplifying. 480 equals, for distributive property, 2 times 30, which is 60, plus 2 times W, which is 2W, plus 2W. And then I start simplifying again with like terms. 2W plus 2W is 4W. And then I want to get the W by itself. So the opposite of adding 60, it's a positive 60, so I'm adding 60, would be to subtract 60. Now realize that if I subtract 60 from one side, I've got to subtract 60 from the other side. So now I'm left with 420 equals 4W. And again, 4 times W, 4W. What's the opposite of multiplying by 4? Would be dividing by 4. So I'm going to go ahead and use the pen option here. Divide by 4, and if I do it to one side, I've got to do it to the other side. And then I get 420 divided by 4, which is 105. Now here's the problem, is W equals 105. But that's not the length and the width, is it? So that means that the width is 105 feet, because that's the unit that we're using. And the length is 30 plus the width, right? So the length is going to be 30 plus 105, which equals 135 feet. Now you're finished with the problem.